Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and this video is number 7, I think, in a series of lecture videos on complex numbers. Let's continue from where we left off. Last time we were talking about finding the roots of a complex number, and we said that a complex number has 2 square roots, 3 cube roots, and 5 fifth roots, and so on and so forth. So the nth roots, in other words. And this was an exercise. Hopefully you were able to do it. And I think one of the users, I can't remember his name, but there was an answer. I think his name is Sean, maybe. Forgive me if I got it wrong. But anyways, you can see it in the comment section. So today we're going to talk about the trigonometric functions. What are they? Sine and cosine and maybe tangent. So to be able to find trigonometric functions for complex numbers, we're going to use the identities, the Euler identity or Euler's formula, which gives us a beautiful relationship between an exponential and sine and cosine. So it's really nice, especially when you replace theta with certain values. But anyways, let's get to the chase, or cut to the chase, right? That's what it is. So we have e to the power I theta is cosine theta plus I sine theta. Now if you replace theta with negative theta, you get the following. Here's one thing you need to remember. Cosine is an even function, so this is going to be cosine of theta, but sine is an even function, so it's going to bring out the negative, and this is going to give you negative I times sine theta. So this is going to be e to the power negative I theta. This is going to be e to the power I theta. Here's what I'm going to do. I'm going to go ahead and add these up, and when I add these two equations, I'm going to get e to the power I theta plus e to the power negative I theta equals the negative sine theta and positive sine theta. They're going to cancel out, giving me 2 cosine theta. And this is awesome because we can divide both sides by 2 to get the value of cosine theta. And this is a beautiful identity. I'll tell you what you can do with this, a lot of good things, but this is cosine. And instead of adding these equations, if you subtract them, then the cosine is going to cancel out, and you're going to get the following. Sine theta equals e to the I theta minus e to the negative I theta divided by 2i. Because sine theta has a coefficient of I, you're going to have twice that. Make sense? So we got the value of sine and cosine, beautiful, in terms of exponentials. But not only just exponentials, complex exponentials. Because think about it, e to the power I theta is actually a complex number, isn't it? It is cosine theta plus I sine theta. So a number whose argument is theta, pretty much, and r, the modulus, is 1 in this case. Okay? Cool. Now, what can we do with this, right? Well, we can go ahead and do a lot of good things, like I said earlier, but let's go ahead and start by finding cosine of I. And I'm just gonna copy that equation here so we can use it. Cosine theta is e to the I theta plus e to the negative I theta divided by 2. So what I need to do to evaluate cosine I is to replace theta with I. Okay? Can theta be complex? Of course. So replace it with I. You're gonna get e to the power I, e to the power negative I, which means I times I. And I times I is I squared, so this is going to be e to the power I squared plus e to the power negative I squared divided by 2. What is I squared? Well, that was one of the first things that we talked about. Remember, I think it was in the first video. You can check it out in the description. There's a link. But I squared equals negative 1. By definition, right? We define the number whose square equals negative 1, so that when we square root negative 1, we get a complex number. But I squared is not complex, it's real. It's real. I mean, are complex numbers real? That's a different discussion. But anyways, I squared is equal to negative 1. If you plug it in, you're going to get e to the power 1 plus e to the power negative 1 divided by 2. I didn't write the 1 because it's the same as e. And now I have the following. This can be written as e plus 1 over e divided by 2. If you make a common denominator or multiply the top and the bottom by e, you're going to get, for cosine of I, you're going to get e squared plus 1 all over 2e. And this is pretty interesting in my opinion, because I is complex, cosine is trigonometric, and guess what? Cosine of I is real as it can be. Anyways, let's take a look at another problem, which is also fairly interesting. I believe we have done the cosine version on my other channel, Cyber Math. You can check it out. If I remember, I'll try to add a link here, card here as well. But what is sine x? Try to remember that. It is e to the ix minus e to the negative ix divided by 2i. Remember, with the sine, there's always a 2i at the bottom, not just a 2. Okay? So hopefully that'll help you remember it. Now, we got to set it equal to 2 because sine x equals 2 is our equation. And let's see if the answer is going to be real or complex. Make a guess and hold on to it. Now, here's what we're going to do. We're going to solve this problem, but I have the e to the ix and e to the negative ix. So I can go ahead and set e to the ix equal to something. How about a t? Let's use substitution. And e to the power negative ix just becomes the reciprocal. So we get the following. T minus 1 over t over 2i. And if you multiply, you're going to get 4i. Let's go ahead and multiply by t. T squared minus 1 is equal to 4it. And then it, information technology. Put it together and then solve using the quadratic formula. Now, what is the quadratic formula? Or you can complete the square if you want, but I'm just going to use the quadratic because that's kind of fun. T equals negative b plus minus the square root of b squared. Negative 4i, if you square that, you're going to get 16i squared, which is negative 16, right? Minus 4i, that's going to give you a positive 4, right? And divided by 2, which is 2a. Negative 16 plus 4 is negative 12. Square root of that is 2 root 3i. So we're going to get something like this. 4i plus minus 2 root 3i divided by 2. And obviously this can be divided by 2. 2i plus minus root 3i. And we can basically just factor out an I and get the answer as a multiple of I. So this is a pure imaginary number. That is what makes sine x 2. And obviously you know that for real values of x, sine cannot be greater than 1. That's the maximum value. In the complex world, you can forget about that restriction. Okay? So that's going to be, oh, by the way, this is not the answer because this is just t. But what is t? T is e to the ix. E to the ix is equal to this. Let's just take one of these and see how this goes. And then I'm going to try to keep it real simple. And if you can just write this as follows. This is a multiple of I, so it's going to appear here. So in other words, its modulus is going to be 2 plus root 3. And its, what's that called? The argument is going to be pi over 2. So we can write this as e to the power I times pi over 2. And then if you ln both sides, you're going to get, or log both sides. Some people say log. But anyways, I can write it as ln hopefully. Ix equals, you're going to get ln of 2 plus root 3. And then plus ln of this, which is I pi over 2. And then finally, if you divide both sides by I, you're going to get the answer. So x is going to look something like this. ln 2 plus root 3 plus I pi over 2 divided by I. And of course, you can multiply the top and the bottom by I, get rid of the negative, so on and so forth. Make sense? Okay, we were supposed to evaluate e to the I. Let's do it. Now, how do you evaluate this? E to the power I theta is equal to cosine theta plus I sine theta. Remember, this is the trigonometric function. What is e to the I? Replace theta with 1. You get e to the I equals cosine 1 plus I sine 1. Of course, 1 is in radians, not in degrees. So you're basically looking at an angle whose arc, the measure it intercepts, is going to be the same thing as the radius. This is how 1 radian is defined. Okay? And the next time we're going to talk about some other things like tangent theta, so on and so forth. But this is the end of the 7th video. Don't forget to subscribe, hit the notification bell, and stay tuned for upcoming videos. See you in the next episode. Bye.